Cool. So overview, what is a method? We kind of just looked at it a little bit like that push function, but basically a method is a function that exists as a property on an object, and it means that you can access it through that bracket or dot notation. And methods have a special thing inside of them, which we just saw a little bit of, that's called this. And this is how you refer to the object that the method resides inside of. Now we'll see that more in depth in the slides. It's just a general overview. So we're going to go over how to create, how to access, and how to run a method, which we just saw a little glimpse of. And we'll go over the introduction to what this is, the keyword this, which is a reserved word in JavaScript. So what is a method? Methods are actions you can perform on a value, like an object, or like a number, or like a string, or an array. Array.indexOf is a method of the array class and objects. So we've been using methods throughout this course, like indexOf. These methods are built into JavaScript. We don't have to define them ourselves. The creators of JavaScript basically built up these huge objects that have a lot of real handy methods on them, and that's what makes the data types that we use in every line of code. So we have countries, and countries has a method inside of it that's given to us by JavaScript called indexOf. And so when we call indexOf Brazil, internally, it's looping through all of the keys that it knows where to start and stop, and it will let us know if it finds the thing or not, which in this case, it will find it, and it will return the index, the numeric index 2 for Brazil. So creating a method. If we have an object and we have some properties on it, we can also, okay, we don't show a function there, but objects can hold any type of value, including functions. So if we add a function to this object as a key, so the key will point to a function. The value is a function, which means that when we access the object at that property, we access the function and we can then invoke it with the curly braces. So over here, we actually get a visual of what that is. We've got this Grace Hopper object with normal key and value pairs that evaluate to strings. First, Grace, last Hopper, rank, rear admiral. But we also have this additional property called myMethod. And if we were to access gracehopper.myMethod and we logged out the type, we would notice that this is a function, which means that we can invoke it over here. And it's the same idea of this order of operations. Before we even come over to this, first we're going to look for a property called myMethod. And JavaScript is going to find it inside and basically plug this function in over here, which means that we can now invoke it. And in this case, when we invoke it, all it does is log to the console, I'm from a method. Does that make sense? So methods on an object generally should perform an action that's relevant to the idea or concept represented by the object itself. That last function was pretty useless. It just logged something out to the console. It didn't need to exist inside that object. In this case, we have another pretty useless function that's just going to log out a quote, but I guess the quote is relevant to Grace Hopper. Maybe that was something that she had said. So we can access it in the same way. It's by dot notation, say quote, or we could even do bracket notation if we stringified, say quote. And once that evaluates to the function, we can then invoke it with the parentheses. And it logs out to the console. It's easier to ask forgiveness than it is to get permission. So one thing that's worth pointing out is that console is an object that's available throughout all of JavaScript. And log is just a method on this console object that basically does the code that actually draws the characters onto your screen. And so that console object has properties inside of it that allow it to know how to behave inside of a browser and how to behave when it's inside of a terminal. And the console will do different things depending on its environment, but that's an object as well. So creating and calling a method. In this case, we're going to add another property called getAge, and we're going to show that it's going to be a function that takes in a parameter called year. And it's basically just going to return year minus 1906, which is 112. And so over here, we have the order of operations again. Before we even worry about this, we need to find the Grace Hopper object, find the getAge property. Then we know it's a function, so we can actually call these curly braces and plug in 2018. So we then step into here. 2018 is now in this local functional scope known as year, and this returns 2018 minus 1906. this whole thing evaluates to 112, and that's what gets logged to the console. So let's give Grace a greet method. Again, this is another function that just takes in a property and it logs out a string with the value that you sent in this case. So when we say greet Karen, it's going to log out, hi Karen, I'm Rear Admiral Hopper. Now, in this case, we are basically typing out a bunch of stuff that already exists on this object, which is why I think that this function is pretty useless. So we actually have, we'll get to this keyword in a second, but in this case, we can actually reference the same object that we're currently writing with the name of the variable that we're going to save it to. So when we call greet Gabe, this time we can access the Grace Hopper object, find the rank property, plug this in, and then do the same for last. So it will log out the same thing, but in this case, we're actually using the properties that are on this object, which means that after line 14, I could go say, hey, gracehopper.last is now equal to some string whatever. And if I call greet again, it will reflect the updated change and the new value that's inside of the object. Does that make sense? I feel like everyone's lost. Okay, so that's generally not a good idea, because if we just change the name of this variable anywhere else, or we say, hey, let my other Grace Hopper equal Grace Hopper, when we call greet method, it's only going to go back to this one. And if we ever overwrite that or we delete it, and we're referencing it from another object, it's not going to be able to evaluate Grace Hopper, and so that's a bad thing. So instead, it's better that we just have flexible access to specifically the objects that we're actually calling the property on. And that's where the keyword this comes in handy. Basically, whenever we have a method on an object, the this keyword will always be a reference to the object that we're actually calling the method on. So when we say gracehopper.greetKate, we plug in Kate for the name, but then we're still able to access these values over here, last and rank, on this, which is this entire object here. So it doesn't matter if we name this Grace Hopper, we can put whatever code we want in here and use this, and it will know what this object is. The other way is really bad practice. I would recommend that you always use the this keyword to refer to the object you want to operate on. Does that make sense?
And that's only if the function is in the object.
Only if it's in the object, yes. So one way that you can try to figure out the value of this is pretty much whatever comes before the dot, wherever this function lies after the dot, this is what the this keyword is. So in this case, inside of gracehopper.greet, this is referring to the object that is currently known as Grace Hopper. And so what this allows us to do is to create multiple different objects that all do the same thing, but now we can call functions on them and only update that object specifically, which we'll go over in some examples at the end of the slides. Anybody lost on this keyword or have a question about it? So this is literally just another reference to the Grace Hopper object on which the function is defined. So in this case now, we can get back returned object. And returned object is a reference to this object in between the curly braces. So now both returned object and Grace Hopper refer to the same spot in memory. And that's a special property of complex data types, that they're not like numbers that only exist on one line and are independent of each other. But that's entirely tomorrow's lecture called Pass by Reference versus Pass by Value, which covers how we can pass around different variables to all point to the same place and keep things updated and in the same state. So this is pretty confusing on this slide, and we have a whole lecture dedicated to that tomorrow. But basically, Grace Hopper and returned object are both referring to the same object in memory. So returned object dot first would equal Grace, and Grace Hopper dot first would equal Grace. And if I said gracehopper.first is now equal to full stack, returned.object.first would also equal to full stack. That's a lot. It shouldn't come up too much today. That will be tomorrow's lecture. We'll go way more in depth and draw it out on the whiteboard on how that all works. And in this case, we can actually do object equality between two objects. And so what this does is it actually checks where in memory the two objects exist or the two variables are pointing to. And if they're both pointing to the same memory address, it will log out true. So that's how we know these two are the exact same object in memory and are both sharing those key and value pairs. This is really putting the cart before the horse. We'll cover it tomorrow. So example calc. Basically, we've got an object that's got two properties called num1 and num2. And we can write this sum function that's always going to give us back whatever the sum is of the current values of num1 and num2. And then we have difference, which does the same thing but subtracts them. So if we log out calc sum right now, what will it return? And if on line 13 I say calc.num2 is now equal to 10, and then I log out calc.sum, what will it return? Exactly. Because whenever we run this function, it's going to look at that current point in time. What is num1 and num2 equal to? So the first time we run it, it's going to be equal to 50. But if I change the property values anywhere later and I call these functions, they'll refer to whatever the current values of these properties are. And so this becomes a bit more reusable. Oh, and that's exactly what they did here. So we switch num2 to 15, and then we subtract 20 from 15 and get 5. So disclaimer, there's so much more to this. It's actually one of the most complex things about JavaScript, and it's why a lot of people really hate JavaScript. For right now, all you need to know is that if you see dot notation, the method the object that comes before that dot will be the value of this inside of the method. And so JavaScript is an object-oriented language, which means objects and their methods play a key role in most production JavaScript code bases. So that's why I was able to show you that we could treat strings and arrays as objects and access properties through bracket notation or dot notation and access their methods as well. And they're all using this under the hood to know which indexes are currently available and how to update their length property. So we're only skimming the surface of this and object methods in this course. There's a lot more to learn as you progress. So, what is a method? Somebody tell me, you're really quiet. Yes, and what value inside of that method will refer to that object? This, yes, exactly. How do we create a method? Yeah, so we create a key on that object or a property, and we set the value equal to a function. And inside of that function, we get the magic power of this. How do we access a method? Okay, well, to be able to call it, we first need to pull up that function value. How can we do that? Yep, or we can even write some bracket notation or string that will evaluate to the same value as that property. And then once we call it, how do we run the method? We just invoke it with the parentheses, special feature of functions. Introduction to this, how can you tell what the this keyword will evaluate to? It's whatever object you're calling it on, which is basically the value that exists right before that dot. Okay, that's a lot. Let's do some quick real-life examples of how things like this work. Did I do a phone book example with this class? Or am I remembering from a long time ago? Okay. So a phone book is something that works very well with objects. Does anybody have any idea what is unique about objects that allow something like a phone book to work? Does anybody have any clue how we would maybe use an object as a phone book and want to get us started. Yeah, Sean.
You do like names as keys and then the phone numbers as values.
Okay, so what if we have Sean and then we have another Sean and he comes in right after you? How can we get back to you?
Do a last name relevant and then have another object inside from the first name.
Okay, so that might work, but again, we have some people that have the same first and last names. So the trick to objects is that we want to use unique key and value pairs, right? So our phone number is unique. So why don't we use the phone number as the key? And then we can pull out the names. And that way we can have, everybody in the world can have the same name, but they won't have the same phone number. And so this is actually called a hash. And a hash is a very complex, scary data structure that you would see on interviews with top coding companies. But really, it's just any object where the keys and values are unique pairs that represent something in real life. And so if we think about real quickly, what if I wanted to store numbers in an array? And I had 100,000 numbers in the array. How would I figure out if I had a number in the array? What's an implementation of how to figure out if something's in the array? I'm sorry? A loop, yeah. So it's what index of does under the hood. And now in my worst case, if you have the 100,000th number in my array, I'm going to look through 100,000 numbers before I say, oh, I found it. Objects have this really cool property where basically if we had a phone book as soon as we type in a key here, even if we have 100,000 keys in this phone book, JavaScript knows exactly where to look in memory to see if that value is present. So we'll do an example tomorrow of how social media works, but basically everything is a huge object. And so as soon as I put in a unique ID relative to you, I can instantly pull up your friends. And I don't have to look through a billion people on Facebook to find the person who's currently logged in. It's called constant lookup time. And so whenever you basically have a set of unique pairs that you're going to need to know if you have something or not, it's always best to use an object, because with an array you have no choice but to loop through it until you find the thing, which means as it gets bigger, your worst case scenario gets worse and worse and slower. So let's say we have a phone book and it's this object here. We're going to store the numbers as a property inside the phone book, and then we're also going to have other properties that are methods that allow us to do stuff with it. So what is a data type that we could basically set the directory property equal to that we'll use to look up phone numbers? So I want to put something here that I'm going to use to add phone numbers and to look them up on. Okay, so I know it kind of sounds like a trick question, but really it's just an object inside of this phone book object. And so the array would give us the problem of as soon as we have 100,000 numbers, it's going to take us 100,000 times to be able to find the worst case solution. So on this phone book, this PB, I'm going to add a function that's called add number. And so this is going to take in a number and a name. What should add number do with the number and name? Okay, so how can we do that? I'm sorry? Okay, so the reference we have to PB, yes, PB would work, but in this case I might want to reuse the phone book over and over. So for now we're going to use this, but PB would totally work because right now I set this thing equal to PB. So we're going to access this property here with the this keyword. So now that we've pulled up this object, basically I just want to save as a key the number, and I want to set that equal to the name. So bracket notation, we need to use bracket notation here because this number can be any single number that comes to us. And so if I get the value 631, I want to plug in basically 631 here. So it needs to be a variable because it's going to be a dynamic key and change every time we call this add number function. Now really we should augment this function to basically not allow you to overwrite somebody's name, and it should also not allow you to give us anything that's not a number. But we'll cover that in a second. How can I remove a number? Delete what? Like this? Yes. Because we need to evaluate that number every time it comes in. We need to evaluate that number into a string and actually find it in the directory. So let's just add some numbers to the phone book. How can I now look at that directory? Okay, that will give us the person whose name is at 1. Oh, so, okay, so unexpected token at line 14. Okay, so I plugged in literally. Okay, that's not going to work just with numbers. We have to plug it in like this. So in this case, we look up the key 1, and we did add it to the string 1, and so we do find it inside. But I just wanted a high-level overview of what the phone book now looks like, and that's it. We basically have these key value pairs, and each key is a number, and the name of the person who is there.
Why doesn't it work with just the number?
Okay, yeah, so right here, it just recognizes this as an integer specifically. And so integers cannot be properties of an object. Strings are properties of an object. So this is just recognizing it as an integer, and basically we can't, this isn't an operator to basically, in this case, this side is going to evaluate to an object, and an object dot an integer doesn't do anything. Like the same way that this is trying to evaluate them, that's actually an operator. But the way we just had it, it's not programmed to do it like that. So it generally is always best to use bracket notation, as I find it a little bit more readable, because basically it'll show you that this bracket is something that will constantly change, whereas directory is something we kind of hard-coded in there. We know directory exists because we wrote it up here. So even if I did add a property, basically XYZ, I would still prefer to access that. Like this, because this shows me, hey, this was a key or a property that kind of got added on, and maybe it's going to change. And I would even set it over here in the same way. And the reason for that is that those are probably parts of my code that change based on the way it's run. Whereas with add number or with directory, I want to make it very clear to the reader that these are things that definitely exist and make up what a phone book actually is. So I think it's generally best practice that when you're writing any dynamic properties that you're adding on to objects after the fact, always do it with the bracket notation and make it clear that you're evaluating something and that this wasn't always there. Directory and add number is always on the phone book, so I find it more readable this way. Okay, so we could write a function that's, let's just do it. How can we loop through this directory and write out every name and number of whoever we have in the directory? I'm just putting more close to real phone numbers in here while I wait for somebody to give me a strategy.
Wanna do a for loop?
Okay, so what does that look like?
For key in.
Okay, now in this case, our keys mean something to us, right? What are the keys?
Phone numbers.
Phone numbers. So it's best practice that we write, let's name the variable actually what the thing is and keep this code as easy as possible to read so we don't have to keep thinking about that and plugging it in ourselves. So let phone number in what? How can we access this? In this dot directory. Yeah, so if we just had directory here, it's going to look on the global scope for a variable that's called directory. Really, directory only exists inside of PB. So yes, I did hear somebody say that we could do pb.directory because we have this up here. But in a minute, I'll show you how if we wanted to reuse this object, that would be a bad idea. So we now have four phone numbers in this directory. How can we get the person?
Did you put a name for forever and add this name? Oh, no, well, is that possible?
Okay, so if we did this dot name and we said just somewhere in here we said this dot name equals whatever, that's the equivalent of going to this, which is the entire phone book object. And that would basically add this property here. And that would get overwritten every step of this for loop. So that's not the best way for us to do it. But basically, we're in a function. We have access to whatever we want to do. So I do like the idea that we can figure out the name first over here and then plug it into the log. But how can we figure out what that name is? Bracket name. So right now we're defining the name. It's not equal to anything yet.
Do bracket phone numbers.
Exactly. And now we could do pb.log and log them out. So I like to pull the variable out right here and figure it out kind of clean and on its own rather than putting this mess in the middle over here. But that would do exactly the same code. So again, what's going on here, if we step through this one at a time, we basically set up this for loop. And what it's saying is for each key that's inside of the directory on this object, which is this entire thing, we're going to take each key and set it equal to phone number. So on the first iteration, and now we see the alphanumeric I was talking about before, but the first key we got was 12393 or whatever. And I actually added that second. So the order didn't matter, but alphanumerically 12 comes before 16. So that was the first phone number we got. We then said, hey, in this, which is this entire object, go to the directory, which is this object over here, and now plug in the phone number, which we just saw the first phone number was this. And we set that equal to name. Then over here, we could just log out phone number, which we're getting from the loop, and then we can log out name or put the whole evaluation again. And so it just does that twice, and we see that it has stored the values that are inside of here.
Can you share that on Slack?
Yeah, I'll share this one on Slack for sure. Now, seriously, this is a complex idea. This is using a directory as a hash, which is what's known as a data structure. And so a data structure is what all algorithms are based off of that tech companies will ask you about. And a data structure is basically using any data type that you know in JavaScript to create ways to store data that make sense in real life. And so once you start to learn them, you'll recognize all sorts of use cases where we can use code to just model real life and build up whatever process we want. So in this case, we noticed phone numbers are unique, and we know that objects allow us to take unique key and value pairs. So we're using an object to represent a phone book. And then we're giving that phone book functionality by creating methods on that object itself. So we can make this as nice as we wanted. We could basically say, hey, only add number if it's actually a number and that number isn't already in the directory. And then because in remove number, we're probably going to say, hey, only add number if it's actually a number. And I know that that logic is going to be repeated. We could even have a function called check if number. And so in here, we can return and now over here, we could say if it's not a number, we can throw an error and stop our user from breaking our phone book. And so now somebody comes along that doesn't read our API, and I have to actually put numbers in here. And we threw the error. Hey, give me a number, you're using this function wrong. And so this is kind of how complex libraries are built up over time. We can create our own errors and throw them whenever the user doesn't use the function as we expected. And in this case, we've kind of now protected our directory. And because I recognize that we want to do this all the time, rather than write this code multiple times all over the place and have to process every time, hey, what is number is integer actually doing? We can write it as one function that's called check if it's a number. And now we can call it in multiple places, and we know that both of these functions are protected. And if I ever decide that I want to, add a more stringent check, I can add something over here as well and another condition. Like maybe the number needs to be greater than 100 or something like that, whatever. Or the number needs to have 9 digits. We can add it here and change this to be called check if it's an okay number. And then I don't have to go touch these again. So that's one little lesson there, that whenever you start to approach your problem, try to break down what the most reusable pieces of the function are going to be that you're going to use over and over. And that's a hint for the Sudoku problem if you still want to try it. But basically, if we have a grid of, let's just pretend it's a 3 by 3, at its core of a correct Sudoku problem, we're just taking different sets of 9 numbers and evaluating whether each of the 9 numbers is unique and that they're all values 1 through 9. So rather than write this big, long program that's going to go through every possible set of 9 and check each of them individually, we can write one function that's called check if the 9 numbers are valid. Then all we have to do is write a function to get a row and to get a column and to get the grid. And then we can return in one line of code, return whether all of the columns are valid, all of the rows are valid, and all of the grids are valid. And so I know I went through that really quickly, but that's one way to break down a large problem into just a few little chunks to focus on at a time, and it'll make your life a lot easier. So I know that's a lot. We could cover another example where basically we would create objects that represent video game characters and we return them out of a function. But if you guys are tired, we can take the break and go right to workshop. Do we want to see a little more, or do we want to test it ourselves? Let's do workshop. Take a 5-minute break.